All right, ladies and gents, we are now in a place to start getting settled in again. I just had to stretch my legs. Solving logarithmic equations. Okay, it's really not all that bad. It almost seems like we've already done it. So let's go ahead and nail our way through it. Okay, so when solving, you really just need to recall how to convert from logs back to exponents and exponents back to logs. Okay, so in the beginning when we explain this, I need to change colors. I have a highlighter right now. If I have a log and a base of A, argument of B, that thing is equal to something X. Well, if I wanted to go into exponential form, okay, then the base is A, the answer is going to be the exponent, and then the argument would be the answer, okay? And likewise, if you want to convert back, you can convert back. So this is actually the means of which we solve. So we condense all of our logs into one big old log, and then we just we solve it. So let's do a real basic one. So for example, this is extremely basic. I mean, not even worthy of even talking about it really, but I think it's good to look at the mechanics. Okay, so solve is what I wanted to say to you guys. Okay. Log base 3 of x equals 4, all right? We know, again, we're solving for x, right? So I can't solve it for x when it's inside of that log, so we have to isolate for it, right? It's like the same thing, right? So isolating for the log. So the way we would think about it, okay, 3 to the 4th power equals x. We break it apart. Okay, so we isolated for the log, technically. Okay, so, and that's 81, and then you'll see that that checks out, okay, when you plug it in there. Okay, and you should always plug it in there. Why? Because, again, log base 3, if I plug in, say, 81, it should give me 4. But more importantly, we just found out that these numbers cannot be negative or 0. It must be positive, right? So these numbers must be positive in order for them to work. Otherwise, the domain restriction that's tied into the log kicks in and says it's not possible, okay? So always make sure you keep this in mind when you are solving, is that that check is extremely important. So, but the general idea behind it is very, 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 very basic, all right? So in general, when we are solving, okay, so when solving, when solving any log, you must isolate for the log. We must isolate. Okay, now I reduced it to just solving instead of solving with the log, because at the end of the day, anytime we're solving, we're always in a mode of isolating. Whether it's an absolute value, we'll isolate the absolute value so we can break it apart and get at the x's. Or clearing fractions, right? So we can isolate for. We're always in this constant search to generally isolate for things, all right, that are our problems. So here we go. Let's isolate for this guy. All right, so here's an example for it. I'm gonna change back to black. Red just seems like it jumps out too much. And okay, solve. Okay, 2 log base 4 of x plus 2 equals 1. Okay, so what does this mean? Okay, well, actually, yeah, 1. Well, first things first is let's isolate for the log by itself, which means I'm going to divide both sides by 2. Okay, and here we are. Okay, so it gives us that, right? Now, log is isolated for. So we spent the time isolating for the log. Completely isolated. Coefficient is 1 on the log. Done, right? Now, let's turn it back into an exponent. So we need to make sure that coefficient was 1, completely isolated for. So 4 to the 1/2 equals x plus 2. And now I think we can grind through this. 4 to the 1/2, well, the square root of 4 is 2. To the first power is 2. So that means that x equals 0 when we subtract 2 over. But you're not done. We better check. All right, so here's the original. Let me get rid of my divided by 2. So here's the check. 2 log base 4 of 0 plus 2 is 2. Well, that gives me a half, right? 4 to the half power is 2. And guys, use the work we already did here. We saw that here already. And that gives us 1, so it helps us check it as well. All right, so boom, done. That equals 1. It checks out. Okay, so 0 would be my only answer. Okay, really, really simple, all right? No big deal. Okay, but the idea is just we're on a pursuit to isolate things in a bigger kind of way. So here's the issue, okay? Example, what happens when I have a problem that looks more like this? And this comes from the fall of 2006. It was number 25. Log base 2 of x plus 11 plus log base 2 of x plus 7 equals 5. All right. So just basically, you have more than one log. The coefficients are not one. There might be two of them, which means double logs, right? What do we do? Okay. So the question now that we're talking about is how. So consider the following. Consider this thing. How do we go about dealing with multiple logs? And it's worth talking about multiple logs. Okay. Well, it turns out there are two or three other laws of logarithms that we need to add to our list that we had from a video a while back. Okay. And I'm going to try to bring up the analogous kind of understanding of them. But I don't bother writing them down in huge detail. So I'm going to go back to our previous video, which is log properties. Bingo. Okay. And this is where we had our list here. Okay. These are all the things from chapter 1, chapter 7, the things we brought up from the first pieces of chapter 9. So now we're in a place to get these other properties. So property 14, 15, and 16 are crucial properties, all right? So here we are. And I don't like blue. I want to write them in black so I could draw attention to this. Okay, so here we go. So 14, the property would be that if I have a log, and again, the theme is the same base. So log base A of x plus a log base A of y, that is equivalent to saying, condensing the two logs together and saying x times y and multiplying the two arguments together. Now note, this only happens when the coefficients are 1. So if the coefficients are not 1, you better figure out something else to do. Okay, so that's the first one. Okay, it's a very, very helpful property, especially when it comes to evaluating things. And I probably should do an example. Maybe we will do an example right now. Okay, so let's flip back here. So let's say, for example, if I was doing more advanced things, well, consider this guy. Okay, let's say I had, and I think I had a good example here a second ago, log base 4 of 2, and it was evaluate. So this is something you might have seen in the past. Okay, evaluate this, and they want you to add it to log base 4 of 32. Well, you could do this. This would be a half, right? And then this guy, well, hold on a second. Now I got some work to do. 4 to what power equals 32? Now we got to play that game. All right, how do I get, well, 4 and 32, the connector is 2. So how do I get 4 to 32? Well, raising it to the 1/2 power. And then 2 to the 32 by raising it to the 5. So this has to be 5 over 2. So literally, this side work means the answer to this thing is 5 over 2. Now, 1/2 plus 5 over 2. Oh, good news. It's already got a CD. So that's 3. Okay, so that you could do it the long way, but the property makes things way easier. My goodness. This ends up being log base 4, and because the bases are the same, if you notice that, guys, they're both, all the bases are the same. So that means I can combine them under the same base, except now it's going to be a multiplication sign. I'm going to multiply the arguments. And do we get the same answer? Well, log base 4 of 64, that exactly is 3. 4 to the 3rd power is 64. If you don't believe me, check it yourself. So that property is very, 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 very cool. All right, so that's one major property that we need to do. But let's go ahead and list out the other ones while we're here already. Okay, so I'm going to go back to properties. Okay, and we just listed out this one. Well, here's another useful guy that we use. Okay, and that is, well, what if we have a log and it has the same base of x, and instead of addition, it's subtraction this time? Okay, well, then we're going to keep the same base like before, except we're going to be dividing the two arguments when we do it. Now, where are these coming from? Okay, they're not made up. And again, before we move forward, let me just remind you, this only works when the coefficients are all 1. If the coefficients are not 1, then we have to do something else. All right, so what is going on here is really, these are really just these properties backwards. Okay, so look at the first one. When the bases are the same, we add the exponents. Well, logs, the answer to them are the exponents, so we're adding the exponents, and hence we're multiplying the bases, which are originally x and y. I mean the exponents, which was originally being multiplied in the beginning. Okay, so this is the cool part about it. So these are just number 1 and number 2 written in log form. Okay, so that's all that is. Let's handle one last guy, and then we're ready to rock and roll. Okay, so the question is, what do you do when the base is not 2 or not 1, when it's something else? Okay, well, let's say the base, we have log base a of x, but this time the coefficient on it is a number, and we'll call it y. Well, turns out this is going to be log base a of x to the y power, okay, and that turns your coefficient 1. So here's the point. If you end up with a problem that's super complex, you can end up throwing the coefficient back in, right? So you'll see a lot of people say shoot this in there, right? Making the coefficient 1, which will then unlock all the other properties to consolidate it down. So it's a very cool thing to do. Okay, so those are the other 3 properties we're going to have to master in order to get through this section. Okay, so let's jump back to section 6.4. All right, so if we go back to solving where we were, okay, we were talking about the great elaborateness of how useful the properties are. All right, well, let's apply it to this property now, this problem now. I'm going to erase all this stuff, get it out of our way. Hopefully you guys don't think this is useful. But you can always rewatch the video as these actual like not recordings, but items are not going to be made available because they're just my rough sketches. All right, so here we go. Good news. Okay, so we're trying to solve this. So let's put it all together. We know that if our logs are isolated for, we could use the definition and turn it back in and solve immediately. Well, I have multiple logs, and I see that they're being added together, and the bases are the same. Well, since the bases are the same, I can make this log base 2, and then I could be multiplying the 2 arguments together. Equals 5. So now there's only 1 log left, and that's kind of the goal. Now some people right now, they want to multiply this out. I'm not one to really multiply things out when it's nightly nested until I'm actually forced to. So now once I'm here, so now the logs are isolated for, so I'm all isolated. Okay, so it's all condensed in. Now, use the definition to transform it back into exponential form. So what's the base here? The base is 2. The exponent will be 5. And then the answer will be x plus 11 times x plus 7. And then, you just got to push through it. Okay, so here we go. This becomes 32. This is x squared plus, I think, 18x. If you don't believe me, do the work yourself. Gives you that. And then, finally, we end up with x squared plus 18x, let's do some math here, 45. All right, so does anybody know how this guy factors? Because if it doesn't factor, then we're going to have to go through some work and quadratic it. Remember, quadratic formula is still the ante to play. All right, so here we go. Let's nail through this. So what do we end up with? It does factor. This gives me x minus 15, I think, or plus 15. No, minus 15. Oh, I made an error. This is a plus sign, guys. Don't fall for my cheap tricks. All right. So what's going to give me 18? I know 45 minutes has 3 sets of 15 in it. So that's got to be the factors equals 0. So x plus 15 equals 0, and x plus 3 equals 0. X equals negative 15, and x equals negative 3. And right now, I'm feeling pretty good about my answers. They feel pretty clean. All right, but we're not done. We for sure have to check them. All right, so let's go ahead and do that. So let's go back to the original. Okay, what's the original? The original is the guy that I wrote on top of over here. So let's see if we could do this. Well, let's see. Log base 2 of negative 15 plus 11 plus stuff. And why am I not writing any more of the stuff? Look what happens. This ends up being negative 4. And we already talked about, because logs have a domain restriction, that number must be always positive. It can't be negative, and it can't be 0. So, because it's negative, he gets tossed out from the party. That simple. Okay? Let's plug in negative 3 and see what we get. So that's done. Maybe we can get past the first step now. Plug in negative 3, and this is what we get. Log base 2 of negative 3 plus 7. And hopefully this gives me 5. I'm not for sure. Log base 2 of 8. Oh, that is 3. Log base 2 of 4. Ooh, 3 plus 2, that's 5. Checks out. Bingo. It's 5. So the answer is only negative 3. That's pretty much it. There is no big differentiation between this. Just make sure you check your problems. Okay. I just want to make sure that let's get one more example in, and I'm going to make it more of a interesting example as it can be a little trickier. So let's be careful here. All right. So what if I had solve, okay, log base 2 of x minus 1 equals, where's it at? There's not a good example on here for me to show you something. All right, fine. We'll back it up a bit. I got like 12 problems, and I figured out I pulled 12 problems that are all the same. All right, so let's get all the logs in one problem. So let's make the base 4 plus log base 4 of x minus 7, which equals log base 4 of 10. All right, so now we have logs everywhere. Logs, 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 logs. No big deal, okay? No big deal. We just need to push through it. So here we go. Here's logs in a bigger kind of way. All right, so it's all about condensing it down into one property. So here we go. I'm going to push all my logs onto one side. Okay, because again, I want to consolidate them together. I do not want to deal with them on other sides. I don't know how to do that. All right, and I don't know enough math. Now from left to right, left to right, I'm going to combine them. So this gives me log base 4 using the addition property, which means multiply the two arguments. And then finally, this one would give me log base 4 of x plus 2 over x minus 7 divided by 10 equals 0. Okay, so first things first, spend the beginning, in this problem again, my bad guys, is solve. Spend the time in the beginning of the problem to just isolate all the logs onto one side, everything that's not a log gets ditched onto the other side, and then condense it down. Okay, so it doesn't always have to be 0, but in this case it is 0 on the right side because all the logs, everything in the problem had a log in it. All right, and we used our properties to get there. So this is us consolidating logs. Okay, now we're going to use the definition next. Okay, so it says 4 to the 0 power has to give me x plus 2 over x minus 7 over 10. Okay, easy. Now, welcome back to chapter 5. This is 1 equals x plus 2 times x minus 7. And I'm going to clear the fraction because who wants to deal with that 10 down there? I'm going to multiply both sides by 10. Okay, now let's distribute this guy out. Okay, if you don't believe me, go to the side and actually multiply it out, and your skills will then be reconfirmed. But I think you guys can do this on your own. Okay, again, if I always will promote that you guys pause the video and actually see if you guys have can do the problems before I start on them. All right, so this is x minus 8, x plus 3, I think is what it factors into. That's nice. So x minus 8 equals 0 means x equals 8. That's 1. And x equals x plus 3 equals 0 means x equals negative 3. All right, so we got these two possibilities, but again, careful. We still need to check and see if they don't violate anything. All right, so let's go back and check it in the beginning. So we got 8 and negative 3. I'm going to start with negative 3. Why? Because negative 3, if I put it somewhere, I'm thinking it can make a domain restriction. So check it out. If I put it here, that's going to go. Done. Right? So negative 3 gives me negative 1 in there. So this doesn't work. Let's try 8 now. So this gives me log base 4 of 8 plus log base 4 of 8 minus 1. 8 minus 8. Oh, 8 plus 2 is 10. My bad, guys. I was like, why is that an 8? Shouldn't it be something else? 10. And this gives me 1. And then they're claiming that it equals that. And it does, because this is 0. I don't know what this is, but that plus 0 has to give me that. So it checks out. Done. So the only answer is the number 8. Okay? Pretty easy, okay, guys? All you really have to do is isolate it. So, but sometimes the isolating part can be difficult. So let's check this out. I'm going to work kind of the same problem. It's not going to work out clean, and I don't want to do it the entire way, but I do want to show you how you'd get there. So like when you get to 1800. So for example, you'll have problems in 1800. It'll say solve, but I don't want to take it very far. I just want to show you on how to maneuver through it. Let's say it said 2 log base x plus 1 over plus log base x minus 2 minus log base x minus 2 equals 1. Okay, let's say it said something like that. Well, no big deal. Okay, we can still do it, but there's an issue here. And what's the issue? Now the properties only work when the coefficients are 1. In this case, it's not 1. This one's 2. Okay, so recall, based off of the last property, I know I just showed it to you. So recall that how in order to unlock the other properties and the 3 properties we had, I wonder if it'll let me copy it from the other paper. It should, right? It is a computer. Okay, so here they are. Copy. All right, so going back into where we are, we end up having these 3 properties, which I can see if I can paste it in there nicely. Okay, so there's our 3. Whoa, let's make it a little bigger. Too big, too big, too big, too big. It's taking up the space. All right, so here are my 3 properties. Done. Okay, so what is the whole point of this? It's to let you know that in order to use the first 2 properties, okay, the coefficients in the first 2 properties, to consolidate them into 1 log, which is what we need effectively, the coefficients have to be 1s. And if they're not 1s, we can't use them. So if the coefficient's not 1, we need to make it the exponent so it becomes 1. All right, so the first move that I have to do is to deal with this guy. Now what's that guy, you say? Well, that 2, well, that's going to become log. The base is still 10, because remember they didn't write it, is x plus 1. And then that's going to be raised to the 2nd power. Okay, minus log base, and I'm going to write the other stuff down. Minus 1 log base. The 1 is obsolete. It's just there because I wanted you to point out the coefficients have to be 1 for this to work. Okay, and again, there's a number on the right-hand side, not 0. Now again, consolidating these, this becomes log base 10 of x plus 1 squared divided by x minus 2, all in the argument. That's equal to 1. Again, I do not know if this is going to work out clean. Probably going to need a quadratic formula of something ugly. But I still consolidated all my logs. It's isolated all together, right? Now finally, base is 10. Raise it to the 1st power. That gives you x plus 1 squared over x minus 2. Okay? And then you just push through it in the normal process. This is 10. We got to clear the fraction, and we got to distribute out the top. So I'm going to distribute out the top, and then I'm going to clear the fraction simultaneously. Again, I'm not sure if this is going to work out, and if it doesn't work out, then we can use quadratic. So this is like on a scale of 1 to 10. This is pushing that 10 or 11 scale difficulty problem. All right, I'm going to subtract everything over, which gives me 8x and plus 21. I'm actually quite sure this guy does not factor. 7 and 3, yeah, that does not factor. So you're going to definitely have to use quadratic formula and then wiggle your way through that. Okay, but bottom line is I wanted to make sure you are understood that to consolidate this 2 in there, you first need to do that before you can combine them into 1 log, which then means now you can finally turn it back into exponential form. And after you turn it back into exponential form, then it's just a normal problem from there. Okay, so that's the moral of the story. So conceptual understanding has to be strong. All right, guys. On the next video, we've nailed solving equations pretty solidly. All the equations are done. The last video we need to talk about is how to use these consolidation equations right backwards, because sometimes it's helpful to break things apart. And we'll talk about that on the next video. All right, guys. See you on the flip side.